Hi guys! Here's another review for Unit 1 for the Statistics unit. And this review are all Regents questions, so it's great practice for our Regents as well. Let's get started. Question 1 says, the students in Miss Glenn's math class earned the grades shown below. Which box and whisker plot represents these data? So to determine which box plot represents these data, first thing we're going to need to do is find our 5-number summary. So in your calculator, you're going to go to Menu, Stat, enter in the data set, which I already did, and then you're going to hit F2 for Calc and F1 for one variable statistics. Scroll down, and we're going to get our min, Q1, median, Q3, and our max. So let's see which one of these matches that. I like to do process of elimination first to get rid of the answer choices that makes no sense, like answer choice 1. So from our calc, we found that the min is 65, but answer choice 1 shows a min of 60. So obviously, it's not going to be answer choice 1. Answer choice 2 shows a min of 65, so that's fine. Answer choice 3 shows a min of 60, so it's definitely not going to be 3. So we're deciding between 2 and 4. Alright, so we have our Q1 is 70. Answer choice 2 shows a Q1 of 70, so that's perfect. We have a median of 82. Answer choice 2 shows a median spot on 80. So it does not look like it's going to be answer choice 2. Our Q3 is 90 and our max is 95. That checks out. But in answer choice 2, we have a median of 80 and our median is actually 82 from the calc. So we could go ahead and eliminate answer choice 2 as well. Obviously, that leaves us with the only other option, which is answer choice 4. But let's double check. We have our min of 65. We have Q1 of 70. We have our median that's a little bit above 80, which represents our 82. We have our Q3 of 90 and our max of 95. So perfect. So our answer here is choice 4. Perfect. Question 2. Create a dot plot to model the following data. So it's in the name itself, right? If they're asking us to create a dot plot, then we should have a graph of dots. So each value in this data set gets a dot on this number line. So in our data set, we have our first value of 85. So I'm going to put a dot right above 85. And then I'm just going to cross this off so that I know that I've done that one already and I don't miss any. Then we have 96. So I go to 96 on the number line. I put another dot for 96. Cross him off. And then you keep going. And that's it. 92, 82, and 90. 90, 88, 95, 85, 88. Done. 90, 87, 96, 82, and 85. And then the last row, we have 92, 96, 85, 92, and 87. And that is it. That's all there is for the dot plot. So each value from the data set gets a dot on the number line. That's it. Question 3. Using his data on annual deer population in a forest, Nodge found the following information. So he found that the 25th percentile is 12, 50th percentile is 15, 75th percentile 22, min is 8, and max is 27. Using the number line below, construct a box and whisker plot to represent the data. So here, there's nothing to put in a calculator. Notice that they didn't give us a data set of numbers. Instead, they gave us the percentiles, right? But we know how to work with percentiles. So just for an example, I'm going to use this box plot up here. We know that our 25th percentile is right here. This is also our Q1. We know that our 50th percentile is right here, which is also our median. And our 75th percentile is right here, which is also our Q3. So, in question 3, if they're giving us the percentiles, we can easily translate those to our Q1, median, and Q3. Therefore, our 25th percentile of 12 is actually our Q1. Our 50th percentile of 15 is actually our median, and the 75th percentile of 22 is actually our Q3. So we have our 5-number summary. We have Q1, median, Q3, min, max. We are going to use our number line to now create the box plot. We're going from 8 to 27, so we could actually go by ones on our number line. That's fine. So if we start here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27. Six, 27, 28, 29, 30. Perfect. So let's create our box plot to match this data. I like to do my Q1, median, and Q3 first because those are the quartiles and that will form the box in my box plot. So our 25th percentile is 12, which is right here. Our 50th percentile is 15, so our median is 15. And our Q3, or the 75th percentile, is 22. So these 3 gets connected to form the box of the box plot. And then we have our min, which is 8. And our max, that's 27. And our min and max are just points that gets attached to the ends of our box plot. And that is it. That's all there is for question 3. Question 4. The data set represents the number of books purchased by 9 book club members in a year. Construct a box plot for these data on the number line below. So here we're actually given a data set. So we need to go to menu, stat, clear out whatever we have in there, and we're going to enter in this new data set to find our 5-number summary. 20, 36, 52, 56, 24, 16, 40, 4, and 28. Then we're going to hit F2 for calc, F1 for one variable stats, scroll down, and we have our min, Q1, median, Q3, and max. So our min, according to our calc, is 4. If we look at our number line, we need to find out what scale they're going by. So it's definitely not going by ones. And is it going by 5, 0, 5, 10, 15, 20? Nope. It is actually going by 4s. So 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, 44, 48, 52, 56, and 60. Okay, perfect. So our min is 4. Q1 is 18, median 28, Q3 46. So I like to start with the Q1 median and the Q3 just because, like I said, those are the quartiles and that will form the box in the box plot. So Q1 is 18, which would be somewhere around here between 16 and 20. And our median is 28, which is spot on right here. And our Q3 is 46, 44, which would be between 44 and 48 over here. These three gets connected to form the box in our box plot. And then our min and max are just points that gets attached on the ends. So our min is 4. And our max is 56. And that is it. Question 5. Using the line provided, construct a box and whisker plot for the 12 scores below. So, again, this is just very repetitive. It's the same thing as before, but I will go over it just for practice. So we're going to go to menu stat again. We have a new data set, so we're going to hit exit. And then you're going to clear out all of this data that's in here. And let's enter the new one. So we have 26, 32, 19, 65, 57, 16, 28, 42, 40, 21, 38, and 10. Alright. And we're going to hit F1 for one variable stats. Scroll down. There's our 5-number summary. So we have our min is 10, Q1 20, median 30, Q3 41, and max 65. So it seems like we could go by 10 on our number line. But then our data set, our box plot is going to be like really close together and small. Like all our quartiles are going to be mushed together. So I would probably go by 2s or 5s on this number line. Let's go by 5. So I'm going to start with 5, 10, 15, 20, 25, 30, 35, 45, 50, 55, 60, 65, 70, 75. Alright, so let's go ahead and make the box plot. Q1 is 20, which is right here. Our median is 30. And our Q3 is 41, which would be just above 40. Okay. These 3 quartiles gets connected to form the box. And then our max and min are points on the end. So our min is 10, attached to the left side. And our max is 65, attaches to the right side. Perfect. The other part of this question asks, determine the number of scores that lie above the 75th percentile. So our 75th percentile, we know that this is the 25th percentile. This is the 50th percentile. This is the 75th percentile. So our 75th percentile is also our Q3, which we found in our calc to be 41. A common mistake here is that some students will write 41 as the answer to this question. But notice that they're not asking us what the 75th percentile is. They're asking us to determine the number of scores that lie above the 75th percentile. So we know that our 75th percentile, or our Q3, is 41. We need to determine how many numbers in our data set are above 41. So let's see. We have 1, 2, 3. 3 scores are above 41. So our answer here for this second part of this question is 3. 3 scores lie above the 75th percentile. Perfect. So just be careful with how you read and interpret that question. Alright, question 6. Robin collected data on the number of hours she watched television on Sunday through Thursday nights for a period of 3 weeks. The data are shown in the table below. Using an appropriate scale on the number line, construct a box plot for the 15 values. Alright, so again, very repetitive, so if you don't need to see how to do this again, you could totally skip this part. And then I'm going to do it, though, just for practice so you can get to see it if you need to. So we're going to hit exit. We're going to clear out all of these values from our data set, from our list, and let's enter the new one. Notice here that this is week 1, week 2, week 3, and they're asking us to look at this all together. So you don't need to have 3 different lists, right? We're going to enter all of these values into our list 1. So we have 4, 3. It doesn't matter whatever order you enter it in, just as long as you get all of the values in there. So if you did the rows first or the columns first, it doesn't matter. 5, 2.5, 3, 1.5, 4, 3, 1, 1.5, and 2.5. We're going to hit F1 for one variable stats, scroll down for a bit. There's our 5-number summary. So we have 1, 2, 3, 4, 5 as our 5-number summary. So on our scale for our number line, we could just go by ones, that's fine. Or you could even go by 0.5. It's a pretty long line. For the sake of time, I'm going to go by 1. So I'm going to go by 0, 1, 2, 3, 4, 5, 6, 7. 6, 7. Alright, cool. So our Q1 is 2. That's right here. Median is 3. And Q3 is 4. This gets connected to make the box. And min and max are points on the end. And there it is. That's the box plot. Second part of this question is asking us to determine the number of hours that lie above the 25th percentile. So, again, as we know, our Q1 is our 25th percentile. Our median is the 50th percentile. And our Q3 is the 75th percentile. So if they're asking us for numbers that lie above the 25th percentile, we're looking at our Q1. We know that our Q1 is 2. Remember, the question is not asking us what is the 25th percentile, right? They're asking us the number of hours that lie above the 25th percentile. So if our 25th percentile right here is 2, we're looking for all the numbers in our data set that are greater than 2. So we have 1, 2, 3. We're not including the 2s. 4, 5, 6, 7, 8, 9, and 10. So we have 10 values in our data set that lie above the 25th percentile. Okay, and then that's all there is for question 6. Question 7. I hope that's not too tiny for you guys to see. The dot plot below shows the number of goals Jessica scored in each lacrosse game last season. Which statement about the dot plot is correct? So here they're asking us questions regarding the mean, mode, and the median. What you should do is put all of this data in your calc to find the mean, mode, and median, and then we can compare or answer choices. So again, menu stat, hit exit, clear out all of that data we just entered, and we're going to enter the data for the dot plot. Okay, remember, in the dot plot, for example, we have 3 dots on 0. That means in our calc, we're going to enter 0 3 times in list 1. So on the calc, I'm going to hit 0, enter, 0, enter, 0, enter. So I put 0 3 times in list 1 because I have 3 dots on 0. Next, I have 3 dots on 1. So I'm going to enter 1 3 times in the calc. So I'm going to hit 1, enter, and then another 1. On 2, we have 4 dots. So I'm going to enter 2 4 times in the calc. And then you keep going. 2, 3, 4. I have 1, 2, 3, 4. 5 dots on 3, so I'm going to enter 3 5 times in the calculator. Whoops, did you catch my mistake? On 2, there were 4 dots, so I was supposed to enter 2 4 times, not 4. Okay, perfect. There's 5 dots on 3, so I'm going to enter 3 5 times. 1, 2, 3, 4, 5. I have 2 dots on 4, so I'm going to enter 4 2 times. I have 2 dots on 5, so I'm going to enter 5 2 times. And then I have 1 dot on 6, so I'm going to enter 6 once. Okay, so 1. It's always good practice with dot plots to double check your data and just make sure that you did everything correctly. Especially me, I make mistakes very easily with these dot plots. 4, 1, 2, 3, 1, 2, 3. Okay, perfect. So now I'm gonna hit F1 for one variable stats. Scroll down. Here's my 5 number summary. All I need from this is my min, mode, max. Min, mode, median. So my min is 0. My median, I didn't even need the minimum. What's wrong with me? The median is 2.5. My mode is 3. My mode is 3 because they're the most dots are on 3. And then my mean is 2.5. In the calc, your mean is X with the little line on top, or the very first number. So let's look at our answer choices. Choice 1, the mean is greater than the mode. So 2.5 is obviously not greater than 3, so it's definitely not answer choice 1. So we can go ahead and eliminate that. Choice 2, the mean is equal to the median. So our mean is 2.5 and our median is 3. Obviously, those are not equal to each other, so it's definitely not 2. Choice 3, the mode is equal to the median. The mode is 3. The median is 2.5. So that is not true. And choice 4, the median is greater than the mean. 2.5 is not greater than 2.5, so it's not that. And if you clock my error, it's actually choice 2. The mean is equal to the median. 2.5 is equal to 2.5. So these two are equal to each other, so it's choice 2. Okay. Let's try not to mess up question 8. Alright, the dot plot below represents the number of pets owned by students in a class. Which statement about the data is not true? Alright, so the median is 3. So again, we're looking at mean, median, and then they're asking us about the IQR. Alright, so let's go ahead and put this in the calculator to get our median, mean, and IQR. Clear out that data. Alright, so again, we have 2 dots on 0. So I'm going to enter 0 2 times in the calculator. We have 2 dots on 1. So I'm going to enter 1 twice. We have 1, 2, 3, 4, 5 dots on 2. So 2 is going to get entered 5 times. 1, 2, 3, 4, 5. We have 5 dots on 3. So we're going to have 3 5 times in the calculator. 1, 2, 3, 4, 5. We have 3 dots on 4. So we're going to enter 4 3 times. We have 2 5s. And we have 1 6. So now we're going to hit F1 for one variable stats. Scroll down. Here's our 5-number summary. We are specifically looking at our median, which is 3. And our mean, X with the little line on top, is 2.75. And our IQR is Q3 minus Q1. So Q3 is 4, Q1 is 2. So 4 minus 2 is just 2. So our IQR is 2. Alright, let's look at our answer choices. Choice 1 says that the median is 3. Remember that this question is asking us which statement is not true, right? So choice 1 is true, so it's not that. Choice 2 says the interquartile range is 2. Yes, that's true. We found it to be 2, so it's not that. The mean is 3, but we found our mean to be 2.75. So choice 3 is not true, so that's our answer. Choice 3. Just for reference, choice 4 says the data contains no outliers. If we were to actually calculate that, the outliers, you'd see that there are no outliers, but you could tell just by looking at this because our data set is pretty symmetric. It's bell shaped, and these values are close together. It's 0 to 6, so there wouldn't be any outliers here even if you calculated it. So our answer here for number 8 is choice 3. All right, number 9. Which data representations have a median of 2? So there's a little bit of calculation here, just specifically for the histogram. If we were to look at these graphs, we can easily see the median for most of them. The box plot, here's our median, it's 2, so that's true. For the dot plot, you can take one value off from each side until you come to the median, and you would see that it is indeed 2. For the histogram, you could do you could do two things. You could write out all of these values by hand to find a median, or you could enter them in the calculator. I'm going to do it by hand just to show you a different way. But if you were putting this in the calculator, on 0, we have our bar stopping at 1. So you would put 0 one time in your list. For 1, our bar stops at 3. So you would have to enter 1 3 times in your calculator. For 2, our bar stops at 5. So you would enter 2 5 times in the calculator. I'm gonna do it by hand to show you. So we have 0 1 time. We have 1 3 times. 1, 2, 3. We have 5 2s. We have 3 3s. 4 4s. 3 5s. And we have 2 6s. Alright, now we're just going to take one off from each side of this data set until we come to the middle to find our median. With our histogram, we found that our median is actually 3. Our question is asking us which data representations have a median of 2. So our answer is going to be 1 and 2 only, which translates to choice 1. Only our box plot and the dot plot had a median of 2. When we wrote out our data set for the histogram, we found that our median was 3. Alright, question 10. Given the following data set, which representations are correct for this data? So the fastest and easiest way to do this is to put this data in the calculator so that you can verify the information for the box plot. So I'm going to go ahead and delete out my data from the calculator and then enter in the new one. 65. And then how many 70s? 1, 2, 3, 4 70s. 3 80s. 185. We have 2 90s in the data set. 3 95s. And then 100. It's 10. Alright, perfect. F1 for one variable stat. Scroll down. Okay, so let's first verify the box plot because that's easy to verify since our 5-number summary is up there. We have that our min is 65. That's true. We have our Q1 is 70. That's true. Median is 80. Perfect. And our Q3 is 95. And our max is 100. So our box plot checks out. Our box plot does represent that data set. What about the dot plot? So we have 165. That's true. We have 1, 2, 3, 4 70s. 1, 2, 3, 4. Perfect. We have 3 80s in the data set, so 3 dots for 80. That works. We have 185, so 1 dot for 85. 2 90s, 3 95s, and then just 100. Okay, so our dot plot also checks out. It also represents the data set. Let's double check the histogram. Okay, so the histogram is the tricky part here. So let's go through that. We have to look at the frequency. So our first frequency is going from 61 to 71. Remember, when we're looking at frequencies for histogram, it's always 61 to one number before the 71. I don't know if I'm making sense. Let me say that again. So, for our first interval, it would be from 61 to 71, but not including 71. So, technically, it's 61 all the way to 70, right? What do I mean by that? So we have 1, 2, 3, 4, 5 numbers that are 60 to 70, right? Or 60 to 71, but not including 71. And that's true for our histogram. We see that on the interval of 61 to 71, our bar ends at 5. If we look at our data set, and we look at all the numbers that are 60 to 71, but not including 71, so 61 to 70, right? There's 1, 2, 3, 4, 5 numbers, and our bar ends at 5. So this works. What about the other interval? We have 71 to 81, but remember, it's going to be 71 to 81, not including this 81, right? This 81 is going to get thrown over and included in the other interval. So technically, it's 71 all the way to 80. So we have 1, 2, 3, right? Remember, we're going all the way to 80, so we're not going to count the 85, right? So we have 1, 2, 3 80s, and our bar stops at 3 for that interval. So that checks out. That works. We have 3 80s, our bar stops at 3, so that's perfect. Next interval, we have 81 to 91. Remember that this is not going to include that 91, right? So technically it's 81 to 90, right? 81 including 81 and including 90. All right, so let's see. We have 1, right? 85. So 1, 2, 3. 3 numbers in our data set that goes from 81 including 81 to 90. Our bar stops right here at 3. We have 3 values in our data set, so that checks out. That works. And then our last interval, 91 to 101, right? Remember, that's going to be 91, not including the 101. So 91 all the way to 100. So 95 will be counted here, which is 1, 2, 3, 4, right? So we have 4 values in our data set. Our bar on the histogram stops at 4, so that checks out perfectly. So each bar in the histogram matched up with what was on our data set. Therefore, our histogram is spot on. So he also represents the data set. Therefore, our answer choice here is choice 4. All 3 graphs, 1, 2, and 3, represents this data set. The histogram, the frequency, the interval is a little bit confusing at times, but all you have to think about it is that whatever number they're telling you in the interval, like 61 to 71, it's always one less than that second number, right? So it's 61 to 71, not including the 71. Then 71 to 81, not including the 81. And then 81 to 91, not including the 91. And then 91 to 101, not including the 101. Right? The number that we're not including gets thrown over. It keeps getting thrown over into the next interval. Right? So it's not counted in the first column to prevent us from double counting one value twice. That's why it's set up like that. Okay, and now I'm rambling. Alright, so that's going to be the end of part 1 for this Regents practice. I'm going to do a part 2 with the other question. Is that all? Oh, that's all. Okay, perfect. I thought there was more. Alright, nice. So I hope this helped you guys study for our Unit 1 test. And then it's also great practice because these are all Regents questions taken from JMAP. Yeah. All right. Bye, guys.